Вітаю всіх. Good morning, everyone. Good day, everyone. Доброго дня. Раді вас всіх бачити на відкритті нашої платформи «Наука для відновлення і сталого розвитку». Сьогодні у нас запрошений спікер і ко-ініціатор цієї платформи доктор Гарик Гутман. Він голова програми НАСА зміни земного покриву та землекористування. Today, our speaker is co-initiator of our platform, the head of Land Caroline Use Change Program of NASA. І я почну з короткого слова. Тобто головна мета нашої платформи – це об'єднання науковців з американських та українських інституцій для досягнення цілей у розвитку української науки і для відновлення, і для розвитку України і співпраці між Україною та Америкою. The goal of our platform is to unite Ukrainian and American scientists from different institutions to achieve essential goals in development of joint research in scientific space and collaboration between our countries in achievement of after-war recovery and sustainable development of Ukraine. Ми хочемо, щоб це була не просто лекція, на якій спікер робить презентацію і ми просто слухаємо. Це має бути живий діалог, тому у нас формат спочатку 45 приблизно хвилин презентація, а потім приблизно 40 до необмеженої кількості часу буде живе спілкування, де ви можете поставити ваші питання нашому спікеру. І, відповідно, продискусувати також із самими учасниками щодо імплементації технологій, щодо можливості співпраці і можливості спільних проєктів. So, our event is not just a lecture, it's first of all dialogue, and we would like to encourage you all after the presentation. So the format will be 45 minutes presentation and from 40 to unlimited time for discussion. We encourage you all to discuss questions that you're interested and discuss questions that you're interested with speaker and with other participants in different fields about possible collaboration, about possibility of implementation some technologies, and about possibilities of use of technologies and methods, and even scientific or academical scientific or academical benefits of research. Це не перша, це перша наша зустріч, але далеко не остання. Ми започатковуємо відкритий формат. Ми вже маємо програму із великою кількістю спікерів по різним напрямкам і різним дисциплінам наук. І ми будемо розвивати цей напрямок, запрошувати нових науковців з України та Америки для того, щоб налагоджувати співпрацю і ростити це ком'юніті зацікавлених в спільних інтересах науковців і академіків. І, відповідно, ми будемо також підлаштовуватися під потреби і питання, і інтереси вас, як учасників, для того, щоб найбільш таргетно робити наші тематики лекцій найбільш цікавими для вас. So it's the first lecture, but absolutely not the last one. We already have a list of participants from USA and Ukraine. They're willing to share with you their experience and knowledge, and it will be in format of open lectures. So we will continue bringing scientists from different topics and different disciplines that are willing to grow this community of joint research interest and possibility of collaborations with you all. And we are gonna adapt to your questions and needs. So we will, based on your questions and interest, we will try to bring the most suitable speakers for your interest. You can see details on our webpage. Ви можете побачити деталі на нашій сторінці. І я хотів би зараз надати привітальне слово академіку Ярославу Степановичу Яцьківу, голові наглядової ради космічних досліджень Академії наук України. Будь ласка.
Дякую. Добрий день, добрий ранок американським колегам. Good day, good morning to everybody from USA, colleagues, and it is my great pleasure and honor to welcome you on such important initiative to create this platform, to consider the very important problem about the remote sensing, about the study of land cover, about to check how our planet is changing. It is very important for Ukraine now. You know in what situation we are. I will not explain you, and in any case, such a problem is worldwide problem, and as I have mentioned, is very important problem from Ukraine. I am not so familiar in this problem. For me, highest level of expertise now. She has organized many good discussion on these topics, and in Ukraine we have had a team of so-called DZZ of remote sensing of the Earth, using the different possibility which we have in former time. Unfortunately, there is no satellite of our national satellite which could provide the data on the remote sensing of the Earth, but nevertheless we use the data from other country. We are living in the open science time, and it is very helpful for us in Ukraine to do what we can to use our possibility. So I represent here the Space Research Council in Ukraine, and in former time, before 2022, we have had a special program of National Academy of Science, which was a good opportunity to promote the scientific research in field of space science and technology. Unfortunately, we have now such a possibility, and we appreciate very high the help of our foreign colleagues over the world. Will help us not only to provide the grants when people are working in another country, but also helping us with the data and provided, for example, National Academy of Science of USA and Polish Academy of Science have organized a program which help Ukrainian scientists to do the special projects inside of Ukraine. So thank you once again, and it is my pleasure to learn something about your topics and to be acquainted with this. I stress once again, very important problem, initiative. Thank you.
Thank you very much. Величезне дякую. Я зараз хотів би попросити перед початком, у нас велика кількість учасників, це дуже радує. Давайте зробимо невеличке групове фото. Ті, хто можуть, будь ласка, виключіть свої камери, і ми зробимо спільну фотографію. Зараз. Аня, можеш, будь ласка, допомогти з фотографією?
Льоня, то ти теж камеру ввімкнив?
Добре. Величезне дякую. А тепер я передаю слово нашому спікеру і одному з ініціаторів цієї платформи, доктору Гаріку Гутману. So now I'm giving a word to one of the initiators of the program and our invited speaker, Dr. Garic Gutman. You can start your presentation.
Okay. Len, do you see me? Do you see me?
Yes, yes, we can see you. Can you turn on presentation mode?
Do you see me now? The presentation.
Yes, yes.
Окей, добрий день. Вітаю всіх. Я не розмовляю мовою українською, so I'll speak English. In the meantime, I'm very happy to see so many people joining our initiative. It's over 80 people, I think, now watching. And this is the first lecture in our series that we discussed and decided it would be helpful for capacity building and trying to bring some continuity in science and connection between Ukrainian early career scientists and American researchers. I'm at NASA headquarters in Washington, managing a program called Land Use Change Program. What you see in the picture is the building where I rarely come now because we have a teleworking, but the new government now is making a new rule that people will have to come every day. So we'll see how it works out. I heard from previous address that we live in open science era, and the satellite data became available and free for many people, and I will be addressing mostly those free data that can be accessed by anyone. And you're welcome to use it for applications. So here we go. The program that I manage is truly interdisciplinary, as it combines physical science and socioeconomic sciences with remote sensing. Why socioeconomic science? Because of merely the name of the program. It's not just land cover, but it's also land use. And land use is by humans. So human dimension is very important when you study changes at the land surface. But the ultimate vision of the program is written here, is to develop the capability for periodic global inventories of land cover land use from space, and also develop scientific understanding and models necessary to simulate the processes and evaluate the consequences and predict changes. So it includes many various components. One is characterization of land cover, then quantification of land cover change, and the drivers of the changes, both in land cover and land use. And natural drivers are, there are different natural drivers, but the biggest probably they're talking about is climate. And the There are, of course, anthropogenic drivers, such as socioeconomic and political drivers, any modification in landscapes drivers, and impacts of land cover, land use change are pronounced in various processes in the Earth system, as carbon cycle and water cycle, surface hydrology, atmospheric circulation, as well as societal changes, and at the nexus of food and energy and water. And we're also trying to predict what may happen with this future changes in scenarios of changes in land cover and land use. There are many questions put in earth science, but those that belong to our program are listed here. One is on detection and monitoring. So what changes are occurring in global land cover and land use? What are their causes or drivers? And impacts, the consequences of land cover and land use change for the sustainability of ecosystem and economic productivity. There are myriads of satellite missions. NASA has been over 50 years in space, and what you see here is those that started around the time when I joined NASA headquarters. This Landsat 7 was just launched when I came in on board. Terra and Aqua satellites were launched at the same time approximately. In the next decade, as SOM NPP and Landsat 8, and more recently Landsat 9 and SWOT, GRACE, ISA. They're all to certain extent valuable for studying changes at the land surface. Then we have International Space Station, which during past few years hosted some instruments on board which are useful for studying land cover, land use change. Those are EcoStress, JEDI, and EMIT, most recently deployed at the International Space Station. I will talk about some of them or most of them during this presentation. NICER is the NASA Indian Space Agency joint mission that is being prepared to launch any moment this year. It probably will happen during the springtime, with the data available a few months later after they're calibrated and tested and so on. Further down the road, there are plans for missions called SBG, Grace C, another SBG, because there are two kinds, and most important for our program is Landsat Next, and I will talk about them in my presentation. So this is the major NASA missions that could be used for land imaging, and some of them are NASA per se or NASA jointly with something. For example, Landsat is actually not a NASA mission. It's a joint mission between NASA and the United States Geological Survey, USGS. I mentioned just now there is a NASA Indian Space Agency joint mission. This is with NICER, and SOM NPP is a joint with another agency, NOAA. I would stratify missions into, first of all, systematic missions. That's what you see on top, systematic missions, and exploratory missions. And systematic missions could be further stratified by spatial resolution. So you have coarse resolution instruments on board, Terra, Aqua, satellites, and SOM NPP. This is MODIS on both. And here's VIRS to continue the legacy of AVHRR before MODIS, and then VIRS. The nominal resolution of the sensors is about a few hundred meters. Aster is a Japanese sensor with a higher resolution than this, but I won't talk about it very much because it's I don't see much of the continuity for that. But it's has been very useful, especially because of its thermal infrared channels. Another strata would be moderate to high spatial resolution. These are Landsat series satellites. Currently, 2 Landsats are flying so that the revisit time for observations is about 8 days because of these 2 satellites. So Landsat 8 and 9, both of them are not very new. Landsat 9 is relatively new. Both of them provide good imagery as compared to Landsat 7 that failed online correction. So we had some issues with quality there. But here, Landsat 8 and Landsat 9, so far, so good. And the future Landsat Next is encouraging because it will be a series of satellites. 3 satellites would be in the Landsat Next mission. I will talk about it in more detail, but just will say that it is planned for the beginning of next decade. The exploratory mission that I mentioned here is one of the shuttle radar topography missions that provided data that allowed us to have global topography map, which is used for geocorrections of Landsat data. And the EO1 mission that had the first hyperspectral instruments on board, and also predecessor of Landsat 8 called ALI. International Space Station that I mentioned has 3 useful instruments. There is also another one which is German Space Agency instrument, but I will focus on these 3 here. And they're rather recently employed, just a few years, and the most recent is EMIT, only a couple of years ago. And then there is a high expectation from that NICER mission that I mentioned, which is planned for this year. So we have optical passive systems. These are coarse resolution and medium to high resolution, and thermal infrared for microstress, active optical with lasers on board, or LiDAR, GDI, and hyperspectral emit, and active microwave with radar on board, NICER, and the details will follow. Just some background, probably most of you know it, but I want to bring those people who are not very familiar with that a little bit up to speed. So we have here graph of atmospheric transmission, and you can see where the atmosphere is more transparent or less transparent, and those that are with high transparency called windows of atmosphere. So on the left you see shortwave windows, and on the right you see infrared windows, and further you have also microwave windows. Those that are shortwave windows are called visible or near infrared, or shortwave infrared. And then we have thermal infrared, and what you see in boxes here, these are 7 bands that are used on Landsat ETM Plus instrument. And then you have also microwave windows. There are many of them. Each of them has a specific range, and the ranges are shown here, not in frequency, but in this wavelengths. They're much longer wavelengths than the visible or infrared. So let's talk about passive and active. Again, most of you know this. Just to refresh some people's memory, that we have passive systems. Passive meaning that they use natural energy source, our sun. So we observe from space by satellite instruments the reflected energy or emitted energy, reflected from the sun or emitted from the Earth system by the surface or atmosphere. And then we have active systems. Active systems have their own energy source. Those include radars and lidars. Radars are active microwave systems. Lidars are active optical systems. Radar are all-weather sensor. If you have clouds, they penetrate through clouds, which is very important in the areas where clouds are persistent. And lidars working in clear conditions, but also very useful. And I'll show you some examples of the applications. Now, some optical or passive optical remote sensing applications that I will show will be about forest change detection, monitoring, urbanization, and agricultural change detection and monitoring. Again, some basics to understand how the passive optical remote sensing could be done. This is the spectral curve of reflectances for healthy vegetation and unhealthy vegetation or soil. And you can see that in the visible part, oops, sorry, clicked on the wrong thing. Do you see the presentation, or it's gone?
We see, but not in full mode.
Yeah. Sorry, I clicked on the wrong. Just try to hide something. Let me try again. Stop share. Okay, do you see it now?
Yes, yes.
Good. All right. So the visible part is quite low. It's reflectance. It's in the red, and then at the boundary between from red to near infrared, which is approximately about 700 microns, you have a jump. This jump, or they call it red edge, here shows the potential of monitoring the change from unhealthy vegetation, senescent vegetation or soil, to healthy green vegetation. If you take a difference between the reflectance of healthy vegetation at this portion and unhealthy vegetation, you will see that it's quite large, which is not the case for the visible part. And this is the index that is being often calculated, which is the difference between this near-infrared and red reflectance, and divided by the sum of it, and it's called normalized difference. So this is the difference, it's normalized by the sum. So this is a principle of looking at the surface where you want to distinguish between green vegetation and non-green vegetation or non-vegetated area at all. And one of the applications is observing and monitoring deforestation. And we were lucky that the Landsat systems program started in early 70s when in Amazonia, Brazil, was still in large areas intact. Like what you see here in 1975 in green, state of Rondônia, Western Brazil, observed from Landsat. It's like virgin jungle, not much of a deforestation was happening there. And then on the right, you see what is observed in 2012. And you can see this green already is intermittent with brown, which means in this color rendition that you have some destruction of vegetation. On the left, you see why it's important, because of over half of tropical forests worldwide have been destroyed in the 1960s, and it's destroyed every second, and deforestation converted to non-forest uses, agriculture, road constructions, and in Brazil specifically, it's done for cattle range. And this is the, so this was Landsat image, and this is the image of the same area already zoomed in, zoomed out using a Terra Modis instrument. And you can see the patterns that reminds you of fish bones. When you eat off the meat of fish, then it becomes something like this. Why is fish bone pattern? Because first the deforestation is conducted along the road, and then smaller roads are built off, and the forests are cut off this main road. And that's what you see in different places. So you can see in 2000 how it looked in this area, or in two areas of Brazil, and then you can see what happened in 2012. It's seriously denuded, and the question is, will it restore itself, or it's being continued to exploit it for deforested and cleared for cattle range, for example, or agriculture. By the way, you will see in some of my slides these links to YouTube clips, and they're quite nice, useful, and I decided to include it. So when you get access to my presentation, you just use this link to see some fun image changes and animations, and some with narration and so on. So you will see that. So based on this principle, as I mentioned before, using vegetation index and classification using visible and near-infrared reflectances, A map of tree cover extent and its forest loss and gain during 15 years of the first 15 years of this century were developed at University of Maryland by the group called GLAD, headed by Matt Hansen and a few researchers there. And this map was derived from Landsat, and in some cases when some missing data were replaced by MODIS data. But what you see, the colors are in green are the tree cover in different hues, and the loss in red and blue in gain. And then when it's mixed, it becomes magenta. So it's for those who know how the colors mix on the computer, you can understand better. But I will dwell on this and explain a little more in a more interesting case for Europe. So one of the applications in animation is to detect changes and monitor urban centers. So urbanization is one of the processes that can be monitored from space because it's quite rapid, and we have plenty of observations globally. So the impacts are on land cover, on air and water quality, its pollution, emissions, and some local climate change. For example, urban heat island effect is quite clearly observed from satellites. So what happens when urban is sprawling or spreading horizontally? First of all, if people moved out of the center, that it increases auto dependence because they need to get to work somehow. So they use either public transportation or their own private cars, which implies that more distances are traveled and there are traffic congestions, and which means that you produce more air pollution, or in this case, greenhouse gas emissions, which affects the climate system or atmospheric composition. On the other hand, the increase of urban areas increases impervious surfaces. What does it mean, impervious? It's those surfaces that replace the natural surface, vegetation, for example. So you have highways, buildings, parking lots, roofs of the buildings already impervious surface. So this decreases carbon sequestration. Carbon sequestration happens when vegetation is healthy and can absorb carbon from air. But if vegetation cover is lost, then you decrease this process of sequestration. On the other hand, when you when you pave more roads, you increase so-called non-point source water pollution. You get more erosion, runoff, lawn pesticides, you increase per capita nutrient loadings and discharges into aquatic environment. So it also affects the water quality, ecosystem health, and you see that the urban sprawl can affect the Earth system in general and the quality of life in particular. This is an example of urbanization that was clearly, nicely observed by Landsat, because in 1972, the first Landsat allowed us to get images of Dubai, where I was just last October for a competition there, and I saw how it's now, but in early 70s it was just a fisherman village. You can see a little bit here, not much built, and then it got urbanized in the 1990s. So the end of the century was a huge increase in development there, and this is what's already in the beginning of this century. Landsat 7 provided us very nice images of this so-called palm installation where they built over the water or these islands and so on. So it's huge constructions. I was staying somewhere in this marina area, and you can see. I think it's just overbuilt, but it's a very popular destination. You probably all know about. To observe changes in urban centers, an interesting source is being used. It's night lights. Night lights data is available from the satellites called SOMI-NPP, an instrument called VIRS. This is a composite obtained from the data for just one particular year. But even then you can see where most of the population is in this world. The western western coast of the United States, eastern part, Europe, India, China. But that was launched just 12 years ago, whereas before that we had data, similar data, from a non-NASA mission, Department of Defense and NOAA joint mission, called Defense Meteorological Space Program, from the instrument called OLS. You can see the systems, how they were launched gradually. It's a series from 92 to 2013 with a new series. And this allows us to see the history of the urban developments and for the last 30, 40 years. And the instrument capabilities has changed. This shows a comparison of the image over area in India around Delhi from OLS instrument on DMSP to the image from VIRS on SOMI-NPP. And you can see how much better it looks because of the spatial resolution, which went from 5 square kilometers to 740 square meters to from also radiometrically from 6 bits to 14 bits. This is an example how this time series could be used in looking at socioeconomic changes. So this is a composite of 3 guns. Oops, sorry. Red, green, and blue, where in each gun you put different years, so you can see the development. So blue is in 92, green 2000, and red in 2009. For those who don't know exactly what is this mixture, I show here this red, green, blue as a mixture. So you see that when the intensity of red, green, and blue is about the same, you get white, high white. And it means that those lights that have been stable in all three decades, 92, 2000, 2009, then you get a stable white light, which shows mostly the big cities, small cities, where the illumination didn't change. On the other hand, if you have a change in night lights, you see different colors. If you had more night light intensity in early 90s or 90 until 92, then and then it goes down, then you would have more blue. Or if you have a recovery of night light intensity in the end of 2000s, then you would have a mixture of blue and red, which would give you more magenta color. And yellow would mean when you mix red and green, which means that it was not bright enough, and then it became bright in 2000 and 2009. So if you think a little longer, you will understand more colors, and you can sit on this picture for a long time, looking at different areas and trying to interpret what's happening. I wanted to bring this picture just because it shows very clearly what happened in Ukraine and Moldova after 92. What happened in 91, probably everyone, if not remembers, but at least knows, because I assume there are young people listening to me who maybe were born even after 91. But you can trust me, it wasn't an easy time when there was a breakup of the Soviet Union, and economically, both Ukraine and Moldova suffered probably more seriously than other former Soviet Union republics. And that's why you can see this bluish color, because there were lights and then it went down because a lot of factories were closed, a lot of cities started doing economy on their illumination, and so on. I think I spent enough time on this picture. Let's go further. This is already easier to understand because it is a one-dimensional thing. There it was like three-dimensional. This is one-dimensional, showing the light intensity from decrease to increase, from blue to red. And I consider this a comparison of the two decades. One is the decade of collapse after the Soviet Union broke apart. So that was the 1990s. And then the decade of recovery, which is the beginning of this century. So deep blue is depressed economies. You can see why I'm talking about it. And red is positive economy and development. What you see is in Eastern Europe, specifically Poland. Then you can see the decade of recovery, where the colors are already not as deep blue like in previous image, more red in Eastern Europe. And also you see urban expansion during that decade of recovery. Of course, Moscow grew, like doubled during that time. And Kiev too. You can see that it's in red, which means that light intensity increased there. This night lights also can be used and is being exploited a lot for looking at the changes in Ukraine during this last 3 years. What you see here is pre-war conditions of this night lights, where September, October, November of 21 were put in red, green, blue, and the white means that the intensity was about the same. So in white, you see most of the urban centers here. And pay attention to the areas in Crimea and eastern Ukraine. Pay attention that the lights in Crimea and Donbass didn't really change very much. Why? That's so. On the other hand, look at Kharkov and look what happened. That's already war impact of 2022 that made all the lights in the country going down because of various reasons, because of the destruction of electrical energy supply, or maybe just darkening because of the war conditions, because to not to attract bombing and various reasons, but you can see how it is substantial. This is time series from 2012 to now, using night lights data from VIRS, because that started only in 2012. And you can see that during the regular times there are changes, but not so serious. Whereas in 22 abruptly down. This is done by various people, but I have a good connection to Chris Elvich, who is now at School of Mining in Colorado, but he was working at NOAA for as long as I remember him. And he has been monitoring these changes and was kind to offer some of the illustrations here. Agricultural monitoring is another application that I will talk about, and satellite data now offer cost-effective, timely, and transparent information of what? Of various things about agricultural practices, crop type, plant health, stress, productivity, and major recent advances in data, cloud and supercomputers, big data analytics allow us to do good monitoring from space. I think the next lecture will be specifically about agriculture by Inba Reshev, and I think also you will have a lecture on methodologies, but applications will be probably a lot on agriculture from Sergey, who is probably listening now. So why do we need agricultural monitoring? This shows world prices on various grains, and you can see how it grew during specific periods of time. And these two spikes in price correspond to particular droughts. One is in Australia and Ukraine, another is in Russia. And then you see the rally during this century. Again, these two, they in different areas. For example, this last one is in 2011 in Africa, Horn of Africa. But what's this? Huge spike in the price of wheat, corn. This is the impact of the war in Ukraine. So it's important to observe and monitor what's happening with the crops to try to predict what will be happening based on the specific political events plus weather conditions. It's not easy, but there are, of course, many millions of dollars invested in this and many thousands of people working on this. What I'm showing now is another application of monitoring agriculture. What happened to agricultural areas after the collapse of the Soviet Union? What you see is the agricultural areas in 2005 derived from MODIS, where you see abandonment of agriculture. This is accompanied because the socioeconomic shock because this collapse of the Soviet Union represented. And what's interesting is to compare the abandonment on one side of the border with Russia and on the other side. So in Belarus, the economic and socioeconomic regime didn't change very much. They continued the socialistic approach, and you can see how in 88 image shows almost no border you can see unless you know that it is the border between Russian Federation and Belarus. 88 was still Soviet Union, so it was Belarusia. And the border is clearly seen in June of 2000, image from Landsat, when you can see that the abandoned fields in Russia are very clear as compared to managed fields, business as usual in Belarus. And that was work by Sasha Prishepov at that time, showing these contrasts. He worked at University of Wisconsin postdoc, and then he's currently at University of Copenhagen. I witnessed myself this land abandonment and overgrowing when I was 15 years ago in Estonia, and they took us on a trip. I took a picture of the place because they said that was a field. And what's going on? It's overgrew with bushes and starting forests. And this is the picture of Sasha Prishepov showing what happens 1 year after the abandonment. It's just overgrown with high grass. 3 to 5 years after the abandonment, with some bushes encroachment, and then already forests started growing. So if you don't cultivate or recultivate land, then in the end, after a decade of no use, it becomes natural vegetation, mixture of bushes and forests. It's very easy to detect it because cropland has a very distinctive signature that's on the right, and the abundant farmland on the left. And you can see the different integrals under the curve because of the difference between greenness in maximum and minimum on cultivated fields is much bigger than in the senescent season, and the abundant fundamental is very little change. And this is the bigger picture of abandonment derived from both Landsat and Sentinel-2 from European Space Agency data done by Volker Radl of University of Wisconsin. And I identified 2 areas in Ukraine showing distinctive patterns of low of fallow, which means not cultivated at this point, and Donbas area, and as compared to green, which is a stable cropland. The spatial resolution of an instrument is quite important for monitoring of agricultural fields. You see here the difference between an image of agricultural area in Thailand and observed from Landsat with 30 meters resolution, and from using the Planet Dove 3-meter image. And you can see that distinction between the fields is very difficult with 30 meters, whereas 3 meters is much better. However, another study, and by the way, that's I give credit to Sergey who provided this image from University of Maryland. And in another project, the data from very high resolution instruments like PlanetScope and Maxar have been compared in Asia. And what was interesting that they found that the field boundaries need to be resolved near sub-meter scale. So 3-meter resolution from Planet may not yield good results as good as Maxar. On the left, you see this Planet mosaic segmented objects, and you can see that the distinction by Maxar world view images, which are in this case, I'm not sure if it is 0.5 meter, 1 meter, or 0.5 meter, allow you to do the segmentation much better. So that's the conclusion for this particular type of monitoring, and also particular area in the world. For example, in the United States, the arable lands, the agricultural fields are very large, and even sometimes you can see the differences in MODIS with few hundred meters, but Landsat is quite fine to distinguish between fields, whereas in Asia or Africa and India, they are quite small, and it's very difficult. So the use of very high resolution data is demanded by users, but they're commercial. They are not cheap. However, there are ways to get it for free. And what's happening is that they are increasing the number of satellites. I mean these entities like Planet Lab or Maxar Technologies, that eventually they have quasi-global, quasi-daily data, which allows you monitoring with a 3-meter resolution with Planet data, as compared to 30-meter resolution from Landsat, which actually does not provide you so frequent data. As I said, the two Landsat satellites provides you only every 8 days, and we have clouds. If you have cloud on that day of the satellite pass, you are out of luck. Whereas here you have daily observations because nearly of the such a big number of satellites, over 200 now, and you have possibility of just picking up clear sky during that period of time when it's clear. Make composites and work similarly that I used to work in my former life. I was a scientist with AVHRR on no satellites. The resolution was what, 1 kilometer at best. Usually it's few kilometers, but because it was daily, it was possible to go through in time series and find some clear observations. And the number of constellations in this case increases. For example, SkySat constellation has now 15 satellites, and the most recent Pelican constellation has 32 satellites just recently launched, and they have 30 centimeter resolution. Rapid Eye, 5-meter resolution. So you have a lot to choose, but if you have money, you can also choose what you want, because not everything is bought. And I will talk about this data purchase in a second, next slide. Maxar has been competitive to Planet in terms of the resolution. While Planet data has 3-meter resolution, Maxar had a meter or sub-meter resolution. But now Maxar is competing also for the coverage because of the new constellation called Legion, 6 satellites, 30 centimeter resolution, multispectral optical image. Who could dream about that, say, 20 years ago? I remember when the first commercial data with few meter resolution was became available. That was from Iconos in about the same time when I came to NASA. It was about 2000, but not. It was a sporadic data, expensive. NASA bought some data, but now you have capability of getting quasi-global coverage almost every day. So you have up to 15 revisits per day now from Worldview. So we're moving towards more and more frequent observations with very high resolution, and that's probably the future. NASA has a program that allows people who are affiliated with NASA, those that are involved in NASA projects, to use data bought by NASA. And there are quite few instances when data that you're interested in was already bought. Also, the Norwegian government bought wall-to-wall tropical forest data, so you can count trees now in various areas and tropics in the world, and the studies being done. For academia, Planet provides free data in some limited size and areas. So there are possibilities of getting data for free if it's too expensive to buy for something that you need, but it's maybe possible to find it. So once it's bought, you can use it. I just wanted to bring some examples of how this commercial data have been used recently. You know that you probably heard about terrible fires in Los Angeles area, in California, and this is an example of Maxar image in one of the areas that were subject to fires. So these are the fires in that area that were delineated by the image from from Maxar Maxar observations. Yeah. So here you can see that. All right, then I was talking about the data availability. So here it's written. You can see this Norwegian initiative and the website link. And what's interesting is that the Bezos Fund, in partnership with this Norwegian initiative, will help to continue providing the world with free access to this high resolution data. And another example is in Kakhovka dam damage that you probably all heard about. That was in June of 2023. The damage was clearly seen on planet images, 3-meter resolution, and you see what was on the 2nd of June and the 1st of June, and then what happened on the 6th of June when the blasts already broke the whole big piece of dam, and water spread through the area. So that's the Kherson view before it was flooded, and that's how it looked after the damage of the dam. So this is the real application of the affected areas by this flood. On the left, you see Kherson before flooding, and this is on the right, you see after the 6th of June when the dam was broken. Again, this is planet data in effect. And Maxar data provides us also views of agricultural areas in that Kherson district. On top, you see before the flood and after the flood. For large-scale assessment, you need already not very high-resolution data, but coarser resolution, so you can see a big picture. And here is the to assess the damage. What you see here is thermal infrared image in Kherson area, in Kakhovka Dam, shown here, and then on the 5th of June, and then the same area from thermal image after the June 6 damage. So sometimes you have to use coarser resolution data like Landsat, or in this case, Sentinel-3 thermal images that provides you a bigger picture, or MODIS sometimes. So a little bit about the instruments on International Space Station. I mentioned EcoStress, JEDI, and EMET. EcoStress is the NASA instrument that is mostly focused on the infrared bands, with one band that is kind of short infrared, 1.6 microns. And it allows you to look at changes in terms of the thermal energy being emitted by the area. In this case, I bring an example of a study area in South America, which shows the evaporative stress by looking at the temperature deviations. And you can see in blue that is lower, and then brown is high evaporative stress, which means that it's probably a drought. EMIT is the most recent instrument deployed at International Space Station. It's an imaging spectrometer, and primarily its use were directed to look at mineral dust changes and heating and cooling in the atmosphere. But there are potential other applications shown here. These are natural hazards like flood extent, what we saw now, looking at surface water changes, system impacts, coastal waters. But in this case, the first light, what you see, is the mineral map in Sahara Desert in Libya. And you can see contrasts in the colors so clearly, which means that there are different minerals in different areas. So this is a global map that was produced using this EMIT data for dry areas over the world, and you can see how Sahara is colorful in terms of different minerals. Kaolinite is a mineral that is used for ceramics and tiles, and it's blue in this case. And hematite is a mineral which indicates the availability of iron ore and oxide minerals found in red, orange, and brown colors there. And goethite is a mineral also found in ore, which is used to make steel, actually, and used a pigment. And this image also, this text also provides you the origin of these names, because it was quite interesting for me to know why these names. The triangle here is this different colors that provides you also how they're mixed. But what you see is better when there is a contrast, blue versus red. But also cyan means that it's blue and green mixture, etc. So again, the mixture, like I showed before in the composite, could be very interesting to analyze these colorful images, where which mineral prevails. Okay, so we talked mostly about active remote sensing, right? But passive remote sensing. And now let's talk a bit about active remote sensing. I mentioned two kinds. One is in microwave, which are radars, and optical, which are lidars. So here I show the various missions that was already launched or will be launched, planned to be launched in various domains of this microwave radiometer and lidars. In lidars we have JEDI. You can also see what we just talked about, passive sensors, optical sensors, and so on. Now let's focus on active remote sensing. So active optical remote sensing could be done from lidars, or this is actually applications of lasers. They provide you a so-called waveform, which gives you this vertical structure of vegetation this way because of the return signal. And this could be used for mapping the height of vegetation, like in this case. Again, to look at the advantages, disadvantages of LiDAR, you can click on this particular link and enjoy in your free time. JEDI was launched about 4 to 5 years ago. It has 3 lasers on board, and they produce data that allow us to map globally vegetation, and not just horizontal distribution, but also the height of vegetation. That was done at that laboratory, GLAD, at University of Maryland, and Petya Potapov is the principal investigator with the team. There they mapped forest canopy height for 1 year of 2019 here. And this allows us to go to higher level products such as above ground biomass. And the density of this above ground biomass is mapped here for the period between April 2019 and August 2021 based on this data. Of course, they combined JEDI data with Landsat data because of the vertical distribution using JEDI and Landsat coverage with 30-meter resolution. Now, active microwave, that was active passive. I'm sorry, active optical. This is active microwave, and radars are particular instruments that you probably all know about because radars are used at your home. Microwave oven is a radar. Radars are used to catch you on the road if you're speeding by policemen. And this is actually an acronym for radio detection and ranging. So it's active. Radar sends pulses through transmitter, and the target reflects the echo and captured by the receiver. It generates and captures the signal. And a relatively high spatial resolution, same as optical. So it's very nice to combine them because optical data are limited to clear sky observations, whereas radar are day, night, and all weather capability. So it's complementary to optical system and especially useful in cloudy areas, as I said. And also provides you complementary data when optical data may not be as frequent as you would like to. There was a recently launched mission called SWOT. It's surface water and ocean topography, so it's mostly directed to study waters of the world, which is what 70% of the globe. But for land applications, it will be also useful because it will collect data over lakes and reservoirs that are large enough for the applications, and the data should not be neglected. It can be accessed through NASA connections, and this is data observed by Ka band radar interferometer. So again, I repeat the advantages of radar data. This is penetrate cloud cover, and it's the dark of the night. And then we have GRACE satellites. This is a series of joint activity, joint undertaking by USA and Germany, gravity recovery and climate experiment. And it's directed at looking at the water storage and using, again, microwave K-band ranging instrument. They've had already GRACE satellites launched almost 20-something years ago. The NASA Grace was deorbited and then followed up by the mission called Grace F4, follow-up observer. And the future Grace C is planned for these next few years. What I show here is the application that is useful for looking at anomalies indicating the drought areas. In this case, it's over Brazil. Northeast Brazil was in a drought in 2014, and you can see where water was lost. It's in red, and in blue where it was gained. It's already towards Amazon and outside of this area. So concerning the near future missions, I already mentioned all of them and stopped at some of them, but the very near future is really next couple of months is NASA, Indian Space Agency, SAR mission, NISAR. I will talk about this a little bit, and SBG in the end of this decade, and Landsat in the beginning of the next decade. So NISAR will observe globally with 12-day repeat cycle. Its instruments will include L-band, 24 centimeters, and S-band. And NASA and India are responsible to one of them. So we will get polarimetric SAR data from that. The observations will cover vegetation distribution, and in this case, it will be possible to map above ground woody biomass density. So that will help estimating carbon emissions for from land use change. So for us, it will be very important, and everybody is looking forward to have this satellite in space very soon. Another mission that I mentioned is SBG, which is Surface Biology and Geology mission, which is a joint enterprise by NASA and Agenzia Spaziale Italiana. It's an Italian space agency, which this mission includes two space crafts. One will collect hyperspectral, visible to shortwave infrared only during the day. Mission will have the instruments, this visible to short infrared will have a 30-meter resolution, and it's planned to be launched in 2029. But before that, there is a plan to launch SBG TIR, which is focused on thermal infrared data. However, it will have also a visible near-infrared camera built by the Italian Space Agency. And this camera will have 30-meter resolution, which is compatible with Landsat. And the thermal infrared instrument, which is being built at Jet Propulsion Laboratory, will have 60-meter resolution. I'd like to mention my regrets to what happened in JPL area recently, because I think 240 people lost their houses there because of the fires. So my heart goes out to them. They lost property, and they lost a lot of their possession. So, but it looks like JPL is coming back to work because they evacuated people from there. Now they're coming back to work. But there are other conditions there that may need to evacuate, because after the fires, they have heavy rains, which led to mudslides. So now again, there's a natural disaster there. So it's unfortunate. Okay. And the main thing from our point of view and Land Coverland News Change is the next Landsat mission called Landsat Next, which is planned in about 6 years from now. It will be not one spacecraft. It will be a constellation of 3 spacecraft, as compared to 2 flying in constellation currently. So they will provide higher frequency every 6 days. They will have also many more spectral bands, 26, which is similar to what Sentinel-2 of European Space Agency has now, and finer spatial resolution, 10 to 20 meters, which is again compatible with what Sentinel-2. So these data, together with ESA, European Space Agency, Sentinel-2 data, could provide very nice data sets because they will complement overlay and so on. You will have many more data with 20 and 10 meter resolution, because now we have to map 30 meter into 20 meter if you want to use both Sentinel-2 and Landsat, or degrade Sentinel-2. So I think that this will allow in 5 years to have some compatible data sets with also compatible wavebands, which is very important when you start combining data for various applications. And I will say дякую and open questions now. Дякую.
Thank you very much. Дякую, доктор Гутман. Тепер давайте перейдемо до живого спілкування. Ви можете задати питання українською, англійською, як вам зручно. Якщо українською, я можу перекласти. Проте, я думаю, доктор Гутман вас все рівно зрозуміє на будь-якій мові, тому...
Трохи розумію.
Так, дякую.
Може, треба translation to English, but whatever.
So you can ask your question to Dr. Garic Gutman on Ukrainian English. There will be no problem. He will understand any language. So we are coming to the question part. Okay. Dmitro Zibarov, how appropriate is it to draw conclusions about the state of the Ukrainian energy sector from nighttime lights images, given that we have a curfew?
Oh, you're talking about the recent times, not
Yes.
what I showed, because I showed the economy and energy conclusions from 20, 30 years ago. Yeah. So we're talking about the current conclusions of energy. It's very difficult to interpret because, as I said, it could be the energy related, it could be forcibly darkening. So it's good to have on the ground people helping with interpretation. On a large scale, maybe it is possible to, but if you zoom in and you know that some electrical station was bombed, I think it's quite feasible to to decide that the night lights went down because of that. But in many other cases, it could be different. So I'm not firm in the conclusions. What we provide is the big picture, and then the question is how you interpret it. It's another story.
It's more about interpretation of like consequences of the war. The rejection of nighttime is a consequence of the war, and now let's interpret it. It's a really good question because like on recent conferences, I see some presentations that are trying to conduct studies on social and economical implications of the war. using night times, but a lot of people are not involved in Ukrainian collaborators and they don't really taking into account curfew, комендантська година, or even shortages of time, shortages of energy, or the like schedule of the energy that implied for some cities.
Yeah, it's a combination of these things. Yeah. And by the way, you have other data, not just night lights. So maybe using some other observations, you can make firmer conclusions about your first interpretation. Like emissions of some kind, thermal data. No, that I just off my head, I'm just thinking about other possibilities. Don't just my recommendations to early career scientists that don't focus on just one source. Look at various things. My example was, for example, in my research life, when I was looking at changes over Amazonia in 91, there was a huge eruption of volcano called Pinatubo in the Philippines, where I actually visited one day. And this eruption was so strong that the volcanic aerosols went through into stratosphere. And stratosphere is a place where the tropospheric circulation already is not that important. So there was a main flow which circled these aerosols over the world. And over the tropical belt, observations from optical sensors, and I was working with AVHRR, but it doesn't matter, visible or on Landsat or whatever you use, which requires clear observations, they were all distorted. It was impossible to observe any anomaly in vegetation. For example, I was looking in Amazon, and it's all distorted. It looks like it was huge drought, but it was maybe not. How do you know? So I looked. When you say you have a one window which is dirty, you have a next window to it that is not so dirty. So look there. And so I looked in infrared. And the infrared, it showed that there was a drought at the same time, because the infrared is not as susceptible to distortion of aerosols as the visible band. That's an example. Okay. The same thing when you work with the optical data, and then you have a problem because of clouds or aerosols. Look at microwave. In microwave, you will see changes because the microwave is not susceptible to cloud contamination. Okay, next.
A little bit clarification. Guys, you can just raise hand in Zoom and we will unmute you so you can like have a conversation with our speaker. So it will be much easier. Because Dmitro Zibarov like asking right now, what do you expect from this collaboration project? You can you please unmute I will unmute you, like clarify this question.
Yeah, so the question is, what do you expect as a result, as a product of this collaboration? I know that the idea is to work when the war over with data with to get maximum efficiency of renew of Ukrainian different fields, but how do you think you will get the result? So, like,
You can ask question if in Ukrainian if you're easier.
No, we understand what will be the products or tangible products, results of our initiative. And I think that, Leonid, you can probably elaborate on this better than me. What we
Yeah,
expect,
so
expectations for the
okay,
outcome.
so if you're talking about the platform, the main expectation is that we wanna American researchers like present what they're doing, what their field is about, and what active projects they have, what perspectives for collaboration and education they can propose. And as well as Ukrainian researchers need also to show to Americans what they have, what projects current, what results, and what possibilities for collaboration and in synergy between different institutions, American and Ukrainian. It's possible to advance research and apply research into the action. So like all is about from research to action, but for this purpose, the first that you need to do is at least create a community who are ready to cooperate.
So the main idea is to convey the experience of American scientists to Ukrainian.
And show Ukrainian experience to Americans, because we also see in America and like Europe, there's a lot of projects about Ukraine without Ukraine. And people are missing a lot of important context, and establishing collaboration between American and Ukrainian researchers, it is possible to advance research to the better level and make it more applicable.
Okay, I get it. Thanks.
The next question from Galina Kalashnik. So the year 2025 will see maximum solar activity. How do you prepare satellites for the maximum negative impact of space weather?
I have to abstain from commenting because I don't know very much about the effects of space weather on our Earth observing satellites. I'll have to learn myself. So please Google it, the same thing what I would do.
Okay. Any more questions?
There are effects that are known because we've had them already. For example, debris in space can affect the hardware. There could be some stray lights getting into the sensor and affect the imagery. And I assume some changes in solar activity probably could affect it. But again, I'm just talking about very, let's say, as a dilettante. You really have to Google it because that will go over all the possible information that will condense into the one sentence for you.
Okay. Tom Oda. Apologize, but I can speak up. What is the plan at NASA for helping us to get access to commercial satellite data? The data are not necessarily accessible like NASA or other open data. Also, we need to examine the quality of commercial satellite data before applying them to research and application. General question. I will unmute right now Tom Oda, so you can discuss this question with Garic Gutman.
Yeah, so first of all, I'd like to emphasize again that all NASA data, all NASA products, and now even methods, algorithms, all free to everyone in the world. So data could be ordered, received with no problems, unless you don't have computers or you have miscommunication somehow. But the commercial data has some limitations for people who don't have money, or there are options that I mentioned before. There are for tropics, which you may not be interested. The data was bought already by Norwegian government and will continue because of Bezos' interaction. But if you want particular data, you have to, and if you are in academia, you can look on Planet website whether you can get it for free. And I think the limited size data, you can get it. Another possibility is to try to do it through European Space Agency, because they may have already bought this data, and then they should be very glad to provide you with this free data. And another way is to get involved with some projects that are funded by NASA, and then the NASA investigators, American investigators, could use NASA purchase data or even request to purchase data, and then the collaborators will benefit from seeing the products of this data because they are involved in the projects. Okay, I hope that it explains.
Okay, Tom Oda, if you can, is it working? You can unmute yourself. There's next question from Protasenko. Second. About CubeSat. Protasenko, can you unmute yourself, please?
Yes, sure. Do you hear me well?
Yes.
Okay, so Dr. Gutman, first of all, thank you for this wonderful lecture. It's
Thank
really
you.
nice to see this hopefully plentiful cooperations between Ukraine and the United States in this space science. So my question is about CubeSats particularly, because back in high school I wrote a little article about different propulsion systems used on CubeSats, and I got interested in this whole topic. And so I wanted to ask, maybe you know something about all these surveillance methods you talked about. I want to know how reasonable it would be to install and apply them to CubeSats, or basically any satellites that are considered to be a small type, because Ukraine doesn't have yet capabilities to launch, let's say, full-scale satellites to perform such missions in space, and maybe CubeSats would be a more optimal option for doing these studies.
Well, there are CubeSats, of course, built in various parts of the world. Your country probably is not the launching the civilian satellites is not high priority at this point. They probably launch other vehicles, as far as I know, with other purposes. But if you are interested in research, then what you need is to have cooperation with not just American researchers, but with others who are not in the war, but build and launch CubeSats. They put simple radiometers there, usually the red, green, blue bands, and let's say near-infrared. They're on many simple microsatellites available in various countries. Some universities launch satellites like this just for their own purposes. So what you need is just personal communication and finding the way who can help you with this. I assume that it's probably easier and will give you much more results if you investigate how to use the commercial data for free. The commercial data, I mean, for example, Planet or Maxar, especially if you get some direct communication with them, and especially if you say that you would like to have some understanding of the impacts of the war. I don't know. There could be some interest. By the way, check solicitations from NATO. They may have something on this too. But
Okay, thank
Yeah.
you so much.
It's very good point raised about open access free, very high resolution satellite data. So Planet has a program where universities can apply to get access to the limited amount of Planet data. It will be a quota for each month, but for research and tests, it can be very beneficial, especially in the sphere of CubeSats and small satellites, because you have to understand how not just launch satellite, but how to use it and how to make it operational use, and what lifespan and coverage is possible with such technologies.
I see Polina has hand on.
And 1 second, we have a questions from Анастасія Гаврилова. Чи помічаєте ви вплив екологізації, прагнення до більшого використання екологічних джерел енергії під час аналізу отриманих даних? Якщо так, то чи є він негативним? Do you see some implications of ecologization that will to use of more ecological friendly or renewable energy sources within your analysis of satellite data? If yes, is it negative or more positive?
We have a project that is looking at mapping all solar batteries in a certain area, United States, that could be related to this. What's exactly the question? Whether could you repeat again?
Do you see some implication of ecologization, the will to more use of ecological energy supplies during your analysis of satellite data? It can also, if in terms of power land use, for instance, the planting of solar panels. Right now, a lot of agriculture was converted.
One of the projects suggested to map where the solar panels are, which leads you to understanding better how for cleaner and alternative sources of energy use for ecology. I don't know.
Anastasia, you can unmute yourself if you want more clarify your question.
By the way, I'd like to mention that putting me on the spot with the subjects that are adjacent to my program is okay, but you may not get the answers from me better than if you just Google it. But if you send me a message or through Learn It, I will receive a message with the exact formulation, what you want, then I can further study it and maybe put some pointers where you could learn it from or who you could learn it from and get you contacts, because I'm not a specialist on this, but on the other hand, I may know someone who will know better than me. But again, I think that Google is the best source.
Okay, Bogdan Dar, what are the platforms or sources we can use to learn how to process, analyze satellite data such as LIDAR?
Again, start with the beginning of the question. What is what?
What are the platforms and sources we can use to learn how to process and analyze satellite data such as LIDAR?
Well, we have trainings on various sensor instruments and use of data and use different methods. So I guess during this series of these webinars, you will understand who can help you with what. Perhaps Sergey may even help with pointing at where the LiDAR data are best described, and the training on JEDI, for example, I'm sure there is a training course, and maybe we should have, if there isn't enough interest in that, we should have a training webinar on how to use Jedi.
Yeah, and if it is really interesting, we can also bring people who are directly processing leader data, Jedi data, in a lot of case studies around the world. And if we're talking about training, so NASA has a program, NASA RSET, if I'm spelling
Yes.
it right. They have various training for different sensors and different software that you can use to processing satellite data, including LiDAR data. And Copernicus, Copernicus RAS, I'm not sure. There's another, it's the same ideology training that created by Copernicus program.
Yeah.
That also available on YouTube, available with training and even access to the virtual machines
Yeah,
to hands-on.
but we should maybe poll our audience, and if there is enough interest, for one person, yes, he should do it by himself. But if we have enough interest, then maybe we should have a webinar on that, and we'll
I
find a
think,
person to give this training. It's not
yeah,
bad.
I think we have a nice interest, and moreover, LiDAR technology is very useful, and it's future of remote sensing, and it can be applicable not only from satellite but aero LiDARs.
LiDARs. And I think that at University of Maryland, you have a group that work with Jedi's, with Petya Potapov and others there. So I'm sure that there could be one person who has been working hands-on with this data that could give a very nice presentation for people who want to work with data. And that's it. Yeah, that's
Yeah,
good.
exactly. We have Matt Hanson group, we have Jedi team.
Yeah.
So we have people who operating and using this data.
Yeah.
More questions?
Yes, I have questions.
Sure.
Thank you for your presentation. It was really great. You said about different sources of information and about its analytics for the wide range in time. Yeah. How do you think, your opinion, which source is the best for maybe creating some online app for creating fast analytics? I understand that it can't be created in real time, but as fast as we can receive a new information from satellite. And maybe you know about such applications which already were created.
Give me an example what you're talking about. For example, what because I had so many different things shown. Could you tell me, narrow down your question?
For example, you showed a map of night light, yeah, for Ukraine. And if we can receive this information and information about different damaged on the our ground, yeah, can we create fresh analytics about condition of our land, of our earth? Analytics, not about the last year, yeah, for example.
You
For the
want
last
something
year.
near real-time products.
Yeah.
Well, there are near real-time products developed from various sources, and depends what we're talking about. For example, fires. There is a system that gives fire monitoring over the globe. It's online. You can zoom in and see how many and where fires occur. If you're interested in nightlight data, that's available, but you have to find the way how it's available, but it's definitely free because it's views. But then the question is the product of it, like for example, urban night lights and the change from last year to this year. This is either in research or if it is done operationally, you have to learn where it is done and where it's available. So again, I could probably find people who would say yes, it's available, or they will say no, it's just in research mode. So it all depends upon which process and which product and which area you're talking about. There are some things that are monitored continuously. For example, there are maps of anomalies of vegetation. So you can always find the areas where there is dryness, and this is interpreted as further poor conditions for the crop. So this will be, for example, in next lecture, you will hear about crop conditions, operational products, and so on. So it all depends. It's not all, it's just some, and which one and where and how can be learned by just investigating with appropriate people. So concerning crops, for example, next lecture. Concerning nightlights, I can give you the person who maybe will not give a lecture, or maybe he will. Actually, I spoke with him. Eleni, is Chris Elvich going to give a talk?
I think yes, he was in the
Okay, so
conversation.
so Paulina, you can just ask him this question: is there operational product of this and this and this? And he'll tell you no, or he will say yes, or he will say we are producing, but we are not putting it on. But if you ask us, we can do it for you. So it's all depends upon particular source, and it's not universal. What I would say, there are universal things like, as I said, all NASA data are available for free. That's universal. But which products are operationally produced? Kobe, Kobe, sure. He doesn't like something going on outside. All right. So you just have to address it, subject by subject and data set by data set. Okay.
Okay. Thank you very much.
Welcome.
More questions? You can unmute yourself. Okay. I will ask you like I think it will be interesting for people to know more about networks like Serene, like some regional researchers collaborative or like educational platforms that they can join or participate in some way.
Okay. All right. So there is an international program called, I didn't include it in my talk, but it's called GOFC, GOFC, Gold, GOLD. It's you can put GOFCgold.org as a link, and you can read about it. It's an international program. So one of the big component is the creation and the existence of the regional information networks. And for this audience in particular, it's important to know that there is a so-called South Central East European network, which includes Ukraine, and we have a representative of Ukraine participating in meetings of this Serene network. But what's important, what Lenny mentioned just now about the educational component is these are the workshops of investigators. So if you're interested in participating in workshops, you're welcome. You can learn about the future workshops. And we always invited people. So I know there are some issues for young males to leave Ukraine now, but we had other representatives, female and older people. And also, the next meeting I would like to mention is going to be in Burgas, Bulgaria, in middle of June. Okay, so if somebody wants to go, you can try. Another thing is to know important is that I've been core organizer with Francesco Sarti from European Space Agency in supporting a so-called transatlantic training series, which started and stems from Karlov University in Prague, Czechia, but it's international and directed mostly at East European students. So we had these trainings at various countries of Eastern Europe, and most often adjacent to that regional network meetings, SERIN meetings. So they are before or after the workshop. There is also training, this TAT work trainings. And we always have participation from various countries with some support that is available. And you just have to, again, know how to... can you help Lenny with the link? Also put the link
It's already in chat.
to SERIN?
Yes, SERIN, GOFC Gold.
No, GovC Gold is just international network, but for TAT, that's what's important, because they can see. I can forward you later on because
I already shared SERIN.eu, GOFC Gold
SERIN,
Edu.
yeah, and TAT is should have I think Czech website. That's how it, because it has been run by Przemek from Karlov University. Okay, so this is an opportunity, but there are other trainings besides our own training that I support. As you mentioned, RSET, it's a NASA program, and there are others. So this also can be explained, and actually we can have even a talk about it. I could provide a few slides. You can show what's available for younger researchers in terms of trainings and opportunities. I just didn't want to include this, but I could have this done separately because I have a talk about opportunities.
I think we will invite you again to discuss the questions of trainings and possibilities to be involved for Ukrainian scientists in the SERIN more intensively.
And also there are other things like postdoctorate positions and solicitations for proposals where you can participate as a foreign participant without budget, but still being involved and benefit from this. So it's a different subject. I could have a talk about benefits of participating in the network, benefits for trainings, and opportunities for younger scientists being involved in NASA, something like this. Yeah.
Perfect.
Okay. All right.
Okay.
Done.
Thank you very much, Dr. Gutman. It was amazing presentation. Hope to see you again, and hope also see you in Kyiv after the war. with live
Actually,
presentation.
I would like to mention concerning this GovC Gold and the SERIN, that's the network. We had, as I said, I mean, I was invited, but it's organized in various countries over Eastern Europe. And one of the meetings was supposed to be in 20 in the year of 22 in May or June in Lviv. And you know what happened before June in 2022. So the meeting was cancelled. And I think when it is the first possibility of having a safe meeting there, it will be held in Lviv.
Thank
Not
you. It will be
not
amazing.
probably first will be in where we're planned, in Lviv.
Maybe closer to Odessa, closer to the sea.
Odessa is a very nice place too. Yeah.
Okay, thank you very much. Thank you everybody for participating. Have a good day.
All right. Thanks everybody. Дякую.
Thank you. Bye.
Bye.